today we're going to be installing a brand new GFCI. We're going to be replacing this old guy. You can see it's got this kind of beige tan color. That's ugly. It's kind of gone beyond its life. And we want to upgrade it. So we're going to be putting a 20 amp in. This is a 20 amp circuit. So keep that in mind. If you're going to be replacing a 15 amp and you have a 15 amp breaker, well, you're kind of stuck. You got to stay with a 15 amp. But luckily, I have a 20 amp breaker, so we're going to be replacing it with this guy today. It looks a lot prettier. Let's get to it. Let's go over some tools and supplies. You're going to need a meter of some sort. You're going to need a GFCI, obviously. Get the correct size for your size breaker. As I said, I have a 20 amp breaker, so I'm going to be using a 20 amp. You can tell it's got that like T looking slot. Non-contact voltage tester. Outlet tester. Make sure you have the one that has the GFCI trip feature, because you can self-test these guys, but you can't mimic a GFCI, or a ground fault, I should say. So get one of these. They have the ground fault test option. You're gonna need some pliers, wire strippers, and shout out to my brother-in-law. He got me some America-themed USA Klein screwdrivers. So just various types of screwdrivers, extra wire for the jumper method. We'll get into that later. Get some Wagos, they'll save you some time. Step one, as always, is to shut off the power. So you can see it's energized right now. I'm gonna go identify the breaker, turn it off, and these lights will also shut off. Here we are at the panel. Luckily, this guy is actually labeled bathroom outlet. It's not always that easy. Now that we've shut the power off at the breaker and the lights are off, now we gotta take the cover plate off and we'll move around the non-contact voltage tester and see if it lights up, because just because we identified the circuit that feeds this doesn't mean there isn't any other wires in there feeding a different circuit. You gotta make sure the power is turned off. Let's do that. Now that we got that faceplate off, turn on your non-contact voltage tester, rub it on some clothing, make sure that it lights up and beeps. You heard that beep? I was just picking up static electricity on my clothing. So we know that this guy works. Now, stick it in there, touch the sides. It's not picking up anything. Nothing. Now, this device, safety device, may have failed. So we have to always double check that it still works even after, because say I test this and then thinking it's great, I touch it on live wires and it doesn't beep because, I don't know, the battery died on this thing or something. You have to double check to make sure that this device still works. So in this case, we're not picking up anything, so we're gonna pull the device out by the yokes, that's these metal tabs. We're gonna pull it out, and then we're gonna test one last time for voltage with our meter, just to make sure it's dead. Don't wanna get electrocuted. So I've gone ahead, unscrewed the top and bottom screw. I'm just pulling it out by its yoke. That's these metal tabs. And one thing you'll notice right off the bat, look at, there's no tape on the side. So say somebody at some point, I don't know, broke this off, the faceplate off or something, or it was live and I had accidentally slipped my screwdriver in, well, you would have been electrocuted, or you could have possibly caused a short, or look at all this dust that's built up on there. I hate that. That's why we always wrap it in tape. But as we can see, there's no other circuits in this box. So we'll just confirm one more time that voltage is not present by turning on our meter. This is actually a fluke tester, it's called, but any meter will work. Go to voltage with the squiggly line, that's voltage AC. And we're gonna touch ground, which is this bare copper wire here. And we're gonna touch each side. 0 volts, 0 volts, 0 volts, 0 volts. So at this point in time, we've turned off our breaker. We've now triple confirmed that there's no voltage there. So we're good to pull wires and put on our new device. So at this point, I'm just going to unscrew the wires. Starting with my hot, which is the black wire coming in. Now you'll notice something. There isn't any other wires in this box. Sometimes what you'll have is you'll have wire coming in to the line side. Now the device actually has a line and load. So line is power coming in, And load would be, let's say you have other receptacles, other outlets in the room. Load would go on the other side. So that way, in case this trips, all the other devices in the room also trip in case water gets here. So that's why you have a line and load. In this case, there's only one wire coming into the box, or one cable coming into the box. So it's going to go to the line side of your GFCI, and that's what we're disconnecting now. So disconnecting my neutral, which is the white. And now I'm disconnecting my ground, which is the green wire, or the bare copper wire, which goes to the green screw. So just like that. There we go. Now it's going to be very simple. We're going to do the same thing, reverse order, to install this guy. So because we only have power coming in, we don't have power going out to other devices, we're going to connect to the line side. It literally says line on the bottom of the receptacle of the GFCI. And then there's a load side. Load, again, is if you have other devices. So if you have a wire coming in that comes directly from your circuit breaker, that goes to the line side. And if there's outgoing wires to other devices, it goes to the load side. I sound repetitive, but it's important that you get this right. So I like to land my ground screw first, my ground wire, I should say, first. So ground is the bare copper. And we're just going to sneak it behind the tab there. Beautiful. Now I'm going to use my neutral, which is my white, and that's going to go to the silver colored screw on the line side of the GFCI device. We'll just tighten that up. And you might be wondering why I'm not making the hooks around the screw. That's because a lot of devices, most modern devices now, they have these tabs that you simply just have to strip the wire and stick it behind the tab, and it just crushes it like in between a little plate, just sandwiches it. Now, the last wire to do is your hot black wire, which is going to go to the brass colored screw on the line side of the device. It says line. Tighten her down. Cool. Now at this point, again, just reiterating, if you have other wires which go to the other outlets in your room, those would connect to the load side. White neutral goes to silver, black goes to brass, and you would just tie your ground together. We don't want these flopping around, so we're going to tighten them up just so they're not rattling in the wall there. And now we'll wrap with electrical tape. Here we are. Make sure you get that Super 88 electrical tape. Don't go with some cheapo off-brand. Just not worth it, guys. You want to make sure, obviously, that it's UL listed, just like anything you use, at least if you're in the US. But get the good stuff. It's what pros use because it works, because it's good. Obviously, also, anything I use in my video, I'll link in the description. Beautiful. I just shoved it in the wall. Last but not least, got to put on that faceplate. Drop the faceplate. No, you put on the faceplate. I like to keep them perfectly up and down. And there you go. Out with the old, in with the new. So all we have to do is test it. Turn that breaker back on. Also, now is a good time to label that breaker if it's labeled incorrectly or not at all. We just went and turned it on, and the first thing you'll see is that light is on. All you have to do, reset. Automatically that light will be on. It makes you reset it the first time you use it. So let's go through, let's do the mechanical test. You can see it trips. Press the reset button. Now here's where this device is important. Make sure you get an outlet tester that has the GFCI function. You can see there's a button. And what that does is it connects your neutral and your ground pin together. It simulates a ground fault because all a ground fault does is it senses that there's a current imbalance between the current going back on your neutral and the current going in on your hot leg. So if you have some current, more than 9 milliamps, go through the ground pin, the ground on your GFCI, it trips. So you plug it in. If you don't know what that means, simply it simulates water essentially. If you were to splash water on here. So plug it in. One, we can see we have the two lights on, so we know we wired it correctly. We didn't wire it backwards. There's a whole slew of codes on here that say you have the hot and neutral swapped, you're missing a ground, all these things. But the feature we care about is this test button. So we press this test button, it should trip. Boom, tripped. We'll reset it. Let's try the top. Wired correctly. Boom, tripped. Reset. At this point, we know our device is installed properly and you did a good job. Thanks for sticking around and watching today's video. Hopefully you learned something. This is a super easy project to do yourself at home. You can save a lot of money. Just remember, it's always important to work safely. Make sure you turn off that power. If you're not comfortable, call an electrician, but I think this is a great beginner project. We went from this old looking, I really hate this color, but I understand why they went with it. It's the cheaper option. And we got rid of this old GFCI, upgraded it to a new GFCI, a 20 amp for our 20 amp breaker. Thanks for watching. Make sure you like, comment, and subscribe. And as always, work safely.